I'm John Conkling. I'm an adjunct professor of chemistry at Washington College in Chestertown, Maryland. I wrote a textbook, The Chemistry of Pyrotechnics, Basic Principles and Theory. Everything you see at a fireworks display is chemistry in action. The colors are all produced by very specific chemical mixtures that produce beautiful color flames. The sparks are small pieces of fuel that continue to burn in air. Without chemistry, you couldn't have the burning mixtures. Without the burning mixtures, you wouldn't have fireworks. Every pyrotechnic composition has at least one chemical that's oxygen-rich, an oxidizer. Potassium nitrate, used to make black powder. Potassium perchlorate, used in a lot of color compositions. Strontium nitrate is an oxygen-rich chemical, but the strontium being in there also produces a red flame color. Then you need a fuel that's going to combine with the oxidizer to produce heat. The fuels are things like sulfur, charcoal, aluminum powder, magnesium powder. You vary your fuel to get a specific heat output, specific burning rate, to try to get the exact behavior you're looking for in your chemical reaction. Most people, when they think of fireworks, think of the sky exploding. This is an aerial shell. This is what people go to watch a fireworks display and see. It's a cardboard casing. The bottom has a little pocket of black powder, granular black powder propellant. There's a very important time fuse that goes from the propellant into the center of the casing. That determines when this shell is going to burst up in the air. The inside of the sphere itself has a black powder bursting charge, and then a number of little green pea to marble-sized pellets of chemical mixture that will produce different colors, different visual effects when the shell bursts open. So this device is placed in a mortar tube. A fuse, or if it's going to be electrically fired, a wire, then extends out of the mortar tube. At the exact time you want to fire it, the signal's given, the button's pushed, the propellant ignites and throws this device up into the air. At the same time, this little delay fuse, which is running from the propellant up into the center of the shell, is burning. And then 3, 4, 5 seconds later, depending on how high you want it to go, burns into the center of this shell, lights that gunpowder bursting charge, and boom, blows the shell open up in the sky. And you see the beautiful colors, the sparks, all the effects, the patterns that have been engineered into the device. We produce colors by using the fact that different chemical elements heated to high temperature get rid of this energy by emitting very specific wavelengths of light. Yeah, this is the stock room where we keep a broad assortment of chemicals. Copper oxide, a chemical that will produce a very, very nice blue flame color for us. Now for a red, you'd look for a strontium compound. Here's strontium chloride. Sodium, of course, will produce the yellow-orange sodium silicate. Calcium makes a nice yellow-orange. Here's a calcium nitrate or the calcium carbonate. But if we want a green color, we need some kind of a barium compound. This is barium acetate. You look for chemicals that don't strongly pick up water, that are not hygroscopic. Safety first. Anytime we have students in the lab or I'm doing demos, everybody has to have their safety glasses on. Now, the glasses I'm wearing are polycarbonate lenses, which are shatter resistant. But when I'm around energetic chemicals, I always wear the extra protection of goggles or side shields. I mean, to produce color, you start with a burning mixture. You need an oxidizer and a fuel, and then you add the other ingredients, the color-producing ingredients to it. This is a mixture of potassium perchlorate and red gum. Now, instead of red, now we want to produce green, so we've added some barium carbonate. Blue is the hardest color to produce pyrotechnically. You need perfect chemistry. This is copper oxide. This is a red flame composition from strontium nitrate. It's a very bright flame because it has magnesium, a magnesium aluminum alloy in the composition to raise the flame temperature. I've taken my base mixture and added moderately coarse magnesium. this should produce a nice white spark effect. When I'm not sure exactly what's going to happen when I test something, I'll use a little piece of fuse. And I light the fuse, it gives me a time to step back just a short distance. There goes the fuse. Fireworks make people happy. There's something about watching that night sky explode in color and sparks and noise that I think gets really deep in the human soul, and seeing the night sky explode in fire still brings chills to a lot of people.